Okay, here's another old exam question. This one is about rearrangements again. And so let's see here. We are looking at exam 3 from 1718 spring, and we're going to be looking at number 2. Okay, so we start off with a matrix given in Jordan form. So, the original matrix itself, not given. We don't know. Turns out we're not going to need it. But we are given that, with respect to this basis, V1, V2, V3, V4, the matrix has this form. Okay, so the first question is about, how does a reordering, notice we have 3 different reorderings here of the script basis V. How does a reordering affect the matrix? And what do you get? And specifically, when you reorder the basis, is it also in a Jordan form? So in other words, are these similarities to other Jordan forms, or are these just wacky, who knows what they are, similarities to nothing of relevance? So the way we're going to do these is play the usual game from section 5.3, and that is that when we reorder a basis, so I'm going to take this reordering here. You reshuffle the rows and the columns accordingly. Right? Okay. All right. So specifically, notice that what's happened here is what was the first vector in the basis has gone way on around over here to the end to become the last vector in the basis. And then the others kind of shift over to the left, right? So V2, V3, V4, V1 that was at the beginning is now at the end. Okay, so the rule is that we saw back in section, I think it was section 5.3. Oh gosh, it might have been 5.5, but is that it reorders columns and rows accordingly. So this first row needs to go over and become the last row. And then furthermore, this first column, sorry, I think I said that backwards. This first column needs to come over here and become the last column of the new matrix. And then this first row needs to come over and be the last row of the new matrix. And when you do so, I think it's pretty easy to see that this 5 is going to kind of move over to here. And then when you move the row over, then that 5 is going to come down here and end up there like that. And et cetera for the other entries. It's a matter of kind of keeping track as you make those sort of rearrangements, but you get this as the rearrangement. So this basis yields that new representation of T. Now, is this in a valid Jordan form? So we got to look and see. Is this in Jordan form? That's a Jordan block, and that's a Jordan block, and that's a Jordan block, and this is an eigenvalue block, and all zeros everywhere else. Yep, all the rules are satisfied. So this is a valid Jordan form. Okay, so likewise for the others, totally analogous here with this reordering. Looks like I just kind of turned them all around backwards, 4, 3, 2, 1, right? Instead of 1, 2, 3, 4. Well, you've got to keep track of where those columns go when you turn the columns around backwards. And then likewise, when you turn the rows around backwards, and what you end up with is this matrix. And is that in a valid Jordan? Is this a Jordan form? No, it's not. Look at this. We've got an entry below the diagonal. That's not allowed in Jordan form. So it's not. Okay, etc. All right, so next part of the question, actually the next 2 parts of the question go to fleshing out a little bit more of the details. Here we were, recalling a previous result, The next two parts of the question, we're really going to kind of justify, really make sense out of those two results, those old results. So first step is how does this tell me about the images of the script V vectors? And remember, this is a 5.3 question, really. What it means to have, forget about Jordan form, what it means to have a matrix written with respect to a basis is that, well, we're going to take these vectors and we're going to look at their images by that transformation, and they're written in that language, and those coefficients in that language are what the columns are. Okay, so just interpreting literally then, what does this first column tell me? This first column tells me about the image of that first basis vector, V1. And it tells me how that first basis vector is a combination of its image, that is a combination of these. It's the same basis, but these basis vectors. What are these numbers specifically? Well, these numbers are the coefficients in that linear combination. So nice punchline. These columns pretty much tell you everything you need to know in these equations. So continuing likewise, we get these four equations. Okay, so this is just taking the matrix shorthand and reinterpreting that as algebra describing the linear transformation. Okay. All right. And now we get to something that's, this is kind of where the meat happens. The question asks us to rewrite these same equations with respect to this other basis. And this is a different basis. We've got the, what had been, V1 that had been on the left has moved over to the right, but also the V4 that had been all the way on the right is now all the way on the left. So here I've kind of switched V1 and V4. Okay. And so I want to rewrite these equations with respect to that basis. In other words, I want to reinterpret this linear transformation with respect to that basis, right? And that's what allows me to deduce this matrix. Same transformation with respect to this other basis now. Okay. All right. So for convenience, I have prepared in advance a copy of these equations. And let me just, I had this out of the way to keep it from being confusing. Let's come up here. These are these equations. I just literally copied them. Again, now into a form where I can drag and drop, right? And well, let's see here. I want to rewrite with respect to this basis here. I've got this new basis, V4, V2, V3, V1. That basis is the order then that I need these vectors to go. And that's not the order that they're currently in. They're currently in the order 1, 2, 3, 4. I need them in the order 4, 2, 3, 1. So how do I reorder the equations? You just reorder them. There's no tricky curves here. I'm just literally going to take this equation here and kind of drag it down here. We'll put it where it's supposed to go in just a minute. But and then this I'm going to drag up to here. And now that I've made space, I can put this there. So notice all I've done is reorder the equations so that these are now in the order consistent with that basis as required here, right? That's, what this says here. The fact that I've got script W basis there means I want it, my input vectors are the script W vectors, namely in the order 4, 2, 3, 1, and that's the order I write the equations. Okay. All right, now are we done? Well, no. The thing is, I also need everything to be written, all the results need to be written with terms in that same order. So I need the terms themselves to be in the order where we start with the V4 term, and then the V2 term, and then the V3 term, and then the V1 term. Okay, well, again, it's just a matter of kind of dragging and dropping. In case you were wondering, why did I have these pluses here? Because these are not going to be the leading terms when I'm done with this. Let me move them over here out of the way just for a minute. I need to put these V4 terms first. And then these V1 terms last. And now, as required, I have all of these images. I have all of these images written with terms in that order. V4, V2, V3, V1, right? V4, V2, V3, V1. Okay. So what I like about this point of view on how I've done this, and we've got to spike the football in a second here, in my process here of trying to determine this new J prime matrix, you can explicitly see why we're reordering columns and reordering rows. I mean, it's right there in the process, right? You saw me replace or trade positions of these two rows. And then you saw me trade positions of what are, these two, what are eventually going to become, that appear to be columns. But, and of course, don't forget that this all kind of gets transposed when we come down here, right? So this equation, which by the way, you'll notice, and why don't I go ahead and now that I'm done, I'll go ahead and slide all this down here, which you'll notice is exactly what I've got written there. This equation tells me how to view V4, how to view its images as linear combinations of the W vectors in that W order. And so that equation gives me the first column. That doesn't quite fit onto the screen, does it? Okay. All right. And likewise for the rest of them, this gives me the second column, and this gives me the third column, and this gives me the fourth column. So when I shuffled those equations, I was shuffling columns, right? And then likewise, when I shuffled the order that I was writing down terms, I was in effect shuffling rows. So I think it's a nice little exploration, right? So, why is it, why was it okay what we did up here when we just said, however you reorder the basis vectors, that's how you reorder the rows and columns, and thus giving rise to these matrices. Well, it's because when you reorder basis vectors, you're reordering equations and you're reordering terms. Equations are columns. Terms are rows. So reordering equations and terms is exactly reordering columns and rows. Okay, so I like how this, again, sort of makes it all very explicit in why that works out. Okay, so I hope that's been a useful discussion.